Hello everyone, myself Ankur Patel, and today in this 8th session of projection of solid, we will continue our practice with problems of solids of revolution. In the last session we have discussed an example of the cone, and in today's session we are going to discuss an example of the cylinder. And cone and cylinder both are the example of solids of revolution. So before moving on to the problem, let us first of all discuss what is cylinder and what are the basic dimensional parameters of the cylinder. So what is cylinder? A cylinder is defined as a solid generated by revolving a rectangular plane surface about one of its sides, which remains fixed. It has two identical circular bases. One base is known as the base itself and second will be the top face. Okay, so this is an example of the cylinder. These lines are the imaginary lines and these lines are known as the generators, and generators are the imaginary lines which are generating the curved surface of the cylinder. This is the known as the base of the cylinder. This will be the top face of the cylinder, and an imaginary line joining the center of the top face and the center of the base are known as the axis of the cylinder. So this is an imaginary line joining the center of the top face and center of the base. So this line is known as the axis of the cylinder. Now let us move on to the problem of the cylinder. So the given content regarding the example is a cylinder 40 mm diameter and 50 mm axis is resting on one point of its base circle on vertical plane, while its axis makes an angle of 45 degree with the vertical plane, and front view of the axis is 30 degree inclined with the horizontal plane. 35 degree inclined with the horizontal plane. Draw its projections. So here the condition with the vertical plane and horizontal plane both are given. So again this example is going to be done in 3 different stages. Now to derive the first stage, first of all we have to find out the resting condition of the cylinder. So here in this example it is given that it is resting on one point of its base circle on the vertical plane. So right now the cylinder is resting on one of the point of its base circle on vertical plane. Okay, so let's start by taking this condition in mind. First of all, draw XY reference line. Now here we are going to use the first angle projection method again. So front view will be above the XY reference line, top view will be below the XY reference line. Now here the cylinder is resting on its base circle or one of the point on its base circle on vertical plane. So right now if you want to derive the first stage, or if you want to draw the front view and top view in the first stage, we have to assume that the base and the top face of the cylinder is parallel to VP, perpendicular to the horizontal plane, and axis should be perpendicular to the vertical plane, parallel to the horizontal plane. So by assuming this condition, we are going to draw the front view and top view of the cylinder. So first of all we are going to start with the front view because it is resting on the vertical plane. So to derive the front view, we have assumed that the base is base is parallel to VP, perpendicular to HP, top face is also parallel to VP, perpendicular to HP. So the front view of the cylinder will be a circle having diameter 40 mm. So first of all draw the circle, okay, having diameter 40 mm. Divide the circle into 4 equal parts, A dash, B dash, C dash, D dash, and 1 dash, 2 dash, 3 dash, 4 dash. Here we are going to take A dash, B dash, C dash, D dash as base of the cylinder and 1 dash, 2 dash, 3 dash, 4 dash as the top face of the cylinder. Now here the front view is a circle and top view is going to be a rectangle having shorter edge length equal to 40 mm and longer edge length equal to 50 mm. So let's try to draw the front view, and to draw the front view what we have to do, we have to project all these points vertically downwards. So project all these points vertically downwards. Okay, so this will be the shorter edge length of the rectangle, and to derive the longer edge length we have to measure the axis height. So measure the axis height and draw the rectangle as a front view having height is equal to 50 mm and width equal to 40 mm. And this will be the base of the cylinder. So it will be A, B, C and D, and top face will be 1, 2, 3 and 4. So this will be the front view and top view in the first stage. So front view will be the circle and top view will be a rectangle. Now here the cylinder is resting on the vertical plane. So in the second stage we have to derive the condition with the vertical plane. And here in the example it is given that its axis makes an angle of 45 degree with the vertical plane. So axes are going to be inclined at an angle of 45 degree to the XY reference line. And if we doesn't want to incline the axis directly, then we can also incline C3 edge and A1 edge at an angle of 45 degree, because right now you can see that A1, C3 and the axis are parallel to each other. So the angle of the axis line C3 and A1 is going to be same because all these edges are parallel to each other. So now copy this figure over here by taking the edge C3, incline at an angle of 45 degree, mark the axis, and axes are going to be inclined at an angle of 45 degree also because right now axis and this line are parallel to each other. Mark the points of the base and point of the top face. So this will be A, B, C, D and this will be 1, 2, 3 and 4. So this will be the front view top view inclined at an angle of 45 degree, in which the axes are making making 45 degree angle with the XY reference line. Now we have to draw the front view, and to draw the front view what we have to do, we have to take the locus, we have to draw the locus and the projections. So from this figure we will draw the locus. This will be locus of 4D, this will be locus of 1A and 3C, and this will be locus of 2 and B. Now draw the projections from base and the top face from the top view. Draw the projection. This will be A dash, this will be B dash and D dash, this will be C dash. Now we have to draw the projection of the top face also. So this will be 1 dash, 2 dash, 4 dash and 3 dash. Now to draw the front view, the observer is observing the figure from this direction. So now you can see that the top face is nearer to the observer than the base. Base is away from the observer, top face is nearer to the observer. So top face of the cylinder is going to be visible in the front view, okay, and it will be an ellipse. So what we have to do, we have to draw a freehand curve passing from 1, 2, 3 and 4, and it is going to be visible. Now draw the end generators of the cylinder. So 4 dash D dash and 2 dash B dash will be the end generators of the cylinder. Now we have to draw the base. So the half part of the base is going to be visible. The half part which is in between observer and the XY reference line, that is ABD, is the half part of the cylinder or half part of the base of the cylinder. It is going to be visible because it is nearer to the observer. So this part A dash, B dash, D dash is going to be visible, and this part is going to be hidden in the front view of the cylinder. Now in the last stage and final third stage, we have to derive the condition with the horizontal plane, and the condition is given like this: front view of the axis makes 35 degree with the horizontal plane. Draw the projection. So front view of the axis will be over here. Here we have not shown the axis because it is given that front view of the axis. So there isn't any need to derive the alpha angle in this example. The given angle is alpha angle itself. So we are going to copy this figure over here by taking the line of the axis at an angle of 35 degree with the XY reference line. So what we are going to do, we will take A dash 3 dash at an angle of 35 degree to the XY reference line. So first of all, draw a line inclined at an angle of 35 degree. Now by taking A dash, C dash, 1 dash, 3 dash, this line of the axis, on this line we will copy this figure over here like this. So this will be the base A dash, B dash, C dash, D dash, and this will be our top face 1 dash, 2 dash, 3 dash, 4 dash. Now we are going to draw the top view in the last stage. So to draw the top view, first of all we have to draw the locus from this figure or from the top view in the second stage. So draw the locus from A, B, C, D and 1, 2, 3, 4. So draw the locus. Okay, locus of A, locus of B, D, locus of C. This will be locus of 1, 2, 4 and 3. Now draw the projection from the front view. So projector of A dash, here we will get A1, here we will get B1, C1 and D1. Likewise 1, 2, 3 and 4. Now to derive the top view or to draw the top view, the observer is observing the figure from this direction. So here you can see that the top face 1, 2, 3, 4 of the cylinder is nearer to the observer and base is away from the observer. So top face is nearer to the observer. So in the top view, the top face is going to be visible. So draw the freehand curve passing from 1, 2, 3, 4 with the visible outline. It is going to be visible. Now draw the end generators first of all. So 1A1 and 3C1 are the end generators of the cylinder. Okay. Now we have to draw the base, and the part of the base which is nearer to the observer is going to be visible in the top view. So you can see that A dash, B dash, C dash is nearer to the observer. So in the top view, the part in between A dash, D dash and C dash, that is A, D, C1 is going to be a visible curve, and the inside part, that is A1, B1, C1 is going to be hidden. So this part of the cylinder is going to be visible and this part of the cylinder is going to be hidden in the last stage. So this is the final front view and top view in the last stage, in which the axes are inclined at an angle of 45 degree with the vertical plane, and the front view of the axes are inclined at an angle of 35 degree with the horizontal plane. So this is it for today. Thank you for watching. See you in the next lecture.